Welcome to P-eduKUL digital platform. In the last video, we have seen the derivative for the function applications of derivatives, exercise 4.2. Now we will see maxima and minima. So this is very important concept from the view of examination, because many a times the question comes on this concept. But this is very simple concept actually. There are typical steps through which you can understand this very easily. So a function fx is said to have a maximum value at the point x is equal to c if fx is less than f of c. So for all x is not equal to c, means c is some different value which we are taking, and then we are checking the function with respect to that c, and then the value f of c is called the maximum value of fx. So when it comes to the solving the examination, you will better understand it. But then we will see the theory part of it. The function fx will have a maximum at x is equal to c if fx is increasing. Now when fx is increasing, f dash x is greater than 0. Okay, then for x is less than c and fx is decreasing for x is greater than c. So let's see, this is the figure. Now here you can see that this is a value chosen for x, and then c minus delta, that is the neighborhood values actually we are considering. So one is more than c and one is less than c, and then if you check the value on the graph, this is the graph, right? This is the graph of the equation. On this equation you will find this f of c, this point is f of c, this is f of c minus delta, and this is f of c plus delta. So what do you observe from this figure? At a point c, you can see the function has the maximum value, and below that c you will find the graph is decreasing, like increasing from this side, but then the values are decreasing, that is they are less than fx, and here if you check the values are more than fx. So let's see the more precisely. Now the next is minimum value of fx. So here for minimum fx is greater than fc. There are only two conditions which you have to remember, that fx is greater than f of c and fx is less than f of c. So when the function has the minimum value, fx is greater than f of c, and for maxima you can see that fx is less than f of c. So it is word to word, if you check it, it is exactly reverse. For minimum fx is greater, for maximum fx is less than. So now how do we deal with this? Now again see, this is a curve of the given function. We have considered here one value c, and then neighborhood values, that is c minus delta and c plus delta. And what do we observe? These are the values of f of c minus delta, and this is the value of f of c plus delta. So for f of c plus delta, the graph increases, and here also it decreases in this way. So at x is equal to c, if the function is neither increasing nor decreasing, then the function is stationary at x is equal to c. So this, as and when the examples come, we will see that. So the maximum and minimum values of a function are called its extreme values. Okay, and to find out these extreme values of a function, we use the following test, that is called a second order derivative test. So first order derivative test and second order derivative test, both are there. A function y is equal to fx is said to have a maximum value at x is equal to c if the following three conditions are satisfied. So that is f dash c is equal to 0. From this we will get the values of x. Then f dash c minus h should be greater than 0. If it is less than 0, then h is a small positive number. Here the way we have defined these two values. Okay, and here it is again the same kind of a graph. This is inverted down, this is inverted up. And the function fx, y is equal to fx is said to have minimum value if the following conditions are satisfied. F dash c is 0, this is less than 0, and this is greater than 0. So as and when we will come to the, what you can say, the examples, this all things will be more clear to you. Okay, only you remember that you need to remember the test. So let's see. So if f dash c is equal to 0 and f dash c minus h is greater than 0, then the fc is neither maximum nor minimum, and in this case this is called as point of inflection. Here you can see that this is c minus h, c plus h. Okay, and this is another point, this is the graph. Here it is f of a, f of b. here the interval is mentioned and we are considering the values between these two. So a function may have several maxima and several minima. In such cases, the maxima are called local maxima and minima are called local minima. Means what? Considering that c minus delta and c plus delta, we are actually figuring the values. So it is called as local maxima and local minima. So in this figure, the function has a local maxima at x is equal to a and a local minimum at x is equal to b. Here you can see that. Here it is maximum and here it is minimum. F of b is here. So considering this, and this is f of a. Graphically, I think this figure will depict the more picture about the concept. So let's see the exercise 4.3. We'll start with exercise 4.3. So what we have to do is determine the maximum and minimum values of the following function. So first we will find out the derivative. So differentiate with respect to x. So dy by dx is equal to 2 into this 3x square minus 21 into 2x plus 36 into 1 minus 0. So this will be 6x square minus 42x plus 36. So if I take 6 common, this will be x square minus 7x plus 6. Okay. Now what is our condition? First we need to take f dash x is 0. So this 6 is not equal to 0. 6 we will consider it as a constant. So I'll consider this x square minus 7x plus 6 is equal to 0. Now you know how to do the factors. 6 1s are 6, 6 plus 1 7. So you will get the values of x as x is equal to 6 or x is equal to 1. Okay. Now once you get the values, these are the roots of this f dash x. So let this as x1 as 1 and x2 as 6. And now what we will do? We will find out this f double dash of 1. So f double dash of 1 will be, this is what you can say, this will be f double dash will be 12x, this 6 into this 2x, 6 constant as it is, then 2x minus this 7. So this will be 12x minus 42. And in this we will put the value of f double dash of 1. So 12 into 1 minus 42. So this will be minus 30, correct, which is less than 0. So what we can say that by the second order derivative, f has maximum value at x is equal to 1. Okay. Now we will check for the value, actual value. So f of 1 will be what? 2 into this 1 cube minus 21 into 1 square plus 36 into 1 minus 20. So this will be 2 minus 21 plus 36 minus 20. So now this will come up minus 3. Right. Now for x is equal to 6 we will calculate. For x is equal to 6, f double dash of 6 means we are putting the value in this 12x minus 42. So that will come up plus 30. 12 6 are 72 minus 42. So that will come plus 30, which is greater than 0. And if it is greater than 0, then that will come up as, then we will calculate f of 6. And f of 6 will come as minus 128. Right. So what we can say that function has maximum value minus 3 at x is equal to 1 and minus 128 at x is equal to 6. So that we will write at the end of the statement. So this is the value which is these are the values we are getting. F of 1 is equal to -3 at x is equal to 1 and f of 6 is equal to -28 at x is equal to 6. That's it. इतना ही तो करना है. So what you will remember, what steps you will remember? First you need to differentiate the function with respect to x. पहले x के साथ differentiate करना है. Then that f dash x you have to equate it with 0. Then get the values of x. Obviously you will get 2 values or 3 values according to the equation. And then you have to equate it with 0. Then you will get the values of x1 and x2. That is roots you will get it. Then put that roots into the second order derivative. Okay. And then decide the values. If it is less than 0, then it is maximum, greater than 0, minimum. Now here the function is fx is equal to x into log x. So here we need to differentiate this with respect to x by using UV rule. मेरे पहले वाले videos देखे होंगे तो you will understand the derivative very clearly. Just go through the all videos. So first into derivative of second plus second into derivative of first. So this will come as 1 plus log x. Okay. Now we will calculate one more derivative f double dash. तो f double dash में 1 का 0 आएगा, log x का 1 upon x. So this will be 1 upon x only. And now we will put the value. Now f dash x is equal to 0. So that is 1 plus log x is equal to 0. So if log x is equal to -1, now you will get it here. Log x is equal to -1. That is minus log of e. 1 is log e. So I have replaced this value of 1 as log e. And then eliminating what you can say the xx, this will be e inverse. Now this is log of e raised to -1. That is the negative power I have added to here only. And then that becomes 1 upon e. So this will be log of 1 upon e. And then what you will get it ultimately, x is equal to 1 by e. X is equal to 1 upon e. Now I will calculate f double dash of. Okay, here only I have already calculated f double dash. So now I'll write here f double dash of x, that is 1 upon e, which is e and which is greater than 0. Therefore what we can write, f is the minimum at x is equal to 1 upon e. That's it. And now we will calculate the value. So that is fx is equal to 1 upon e log of 1 upon e. So this will be 1 upon e log of e inverse. That's it. So if I take it this and solve it further, this will be minus 1 upon e. Log a to the base e will be 1 and this -1 will come down to this side. So you will get the values as fx is equal to minus 1 upon e. That's it. If you understand the steps now, how to do it, why to do it, then it is easy actually. It's not difficult. Derivative and applications or derivative are actually easy if you know the rules properly. Okay, so for that be with us on P-eduKUL digital platform and check out our all videos for all the subjects. Then you will feel everything is very easy. Okay, so let's see the next example. Test whether the functions are increasing or decreasing. So now this is again we will do it x square plus 16 by x. So as usual, differentiate with respect to x. So dy by dx, that is nothing but f dash x will be 2x and then minus 16 upon x square. 1 upon x का derivative क्या है? minus 1 upon x square. So this will come out. And we have to do again one more derivative, that is f dash x. तो 2x का आएगा 2 एंड देन 16 तो वैसे ही रहेगा, फिर ये होगा x⁻², इसका डी बाई डी एक्स निकालना पड़ेगा। सो ये 2 तो वैसे का वैसा, ये 16 भी वैसा, x⁻² का -2, x⁻³ सो दिस विल बी 2 plus 32 upon x3. This is the answer. And now I will equate this f dash x with 0. So that is 2x minus 16 upon x square is equal to 0. So I'll get it 2x cube minus 16 is equal to 0. So if I take here that 2x cube is equal to 16, I'll get it x cube is equal to 8. And this implies what? X is equal to 2. Now for this 2, I'll calculate f double dash x. So f double dash already I have calculated. There just I will put the value. That is 2 plus 32 upon 2 cube. 2 cube is 8. 8 4 is 32. So this will come up as 6. And this is greater than 0. And now we will calculate the value. So f of 2 is 2 square plus 16 by 2. That is 4 plus 8, which is 12. And hence our final answer will be what? Hence f is function has minimum at x is equal to 2 and minimum value is 12. That's it. Now the next example. Divide the number 20 into 2 parts such that their product is maximum. So we will write, let the first part of 20 be x. Here the function is not given in the form of equation or something like that. That everything we have to find out. So let the first part be x. Therefore the second part will be 20 minus x. दोनों को मिला के 20 है ना, तो एक x हो गया तो दूसरा 20 minus x हो गया. Now their product is maximum. So first we will calculate their product. So their product will be x into 20 minus x. So this will be 20x minus x square. And this is my function. Okay. Now this is maximum. So first I'll calculate f dash x. So f dash x will be 20 minus 2x. Correct. Now and f double dash. F double dash will be minus 2 only. So the root of the equation, so this will be f dash x is 0. So 20 minus 2x is 0. So you will get it x is equal to 10. And at this value I will calculate. Now f double dash of 10 will remain the same as it is a constant function and this is less than 0. So therefore what we can write? F is maximum. When it is less than 0, it is maximum at point is 10. At x is equal to 10. So the required parts will be 10 and 20. Hence, the required parts of 20 are 10 and the remaining will be 10. 10 minus 10 or 20 minus 10. So that will come up as 10 only. That's it. Okay, now the next question. So see the example now. A metal wire of length 36 centimeter. So this is a perimeter given of a rectangular wire. And then means there is a wire whose length is 36 centimeter and which has to be bent in the form of rectangle. मतलब क्या एक वायर का रेक्टेंगल बना दिया है बस. Find its dimension when its area is maximum. अब ये जो रेक्टेंगल बना है उसका ज़्यादा से ज़्यादा जो भी एरिया है दैट इज मैक्सिमम, तो उसके लेंथ एंड ब्रेड्थ निकालो. तो दिस इज क्वाइट इजी क्वेश्चन इफ यू थिंक ऑफ. So let's see, let x centimeter and y centimeter be the length and breadth of the rectangle. So since perimeter is given, perimeter is 2 times x plus y is equal to 36. So x plus y is equal to 18. This 2 will go to this way. Then y will be equal to what? 18 minus x. So here we got the function in terms of y. Now my area of rectangle, we need to deal with the area of rectangle. So area of rectangle is what? X into y. And then fx is equal to x into 18 minus x. So that will come up 18x minus x square. Now we will take as usual the derivative. Derivative will come up as 18 minus 2x. Then f dash x is 0. This will give me the value of x is equal to 9. See, there are typical steps. First you need to find out the function. Then you need to derive that function with respect to x. Then you equate that first order derivative with 0. You will get the values of x, that is the c, constant values, and then you need to check with the second order derivative test. So here the second order derivative is a constant function, that is minus 2, and hence f double dash of 9 will also be minus 2, which is less than 0. And ये यहाँ पे अगर 0 आ गया तो this is maximum, right? If it is less than value then it is maximum. So area is maximum and length is 9, breadth is also 9. Okay.
So the total cost of producing x units, the number of units are x, is given x square plus 60x plus 50. So the cost is given in the form of quadratic equation, and the price is 180 minus x per unit. So for what units is the profit maximum? So we need to find out number of units. So let the number of units be x, जो निकालना है that we will let it as x. So profit will be what? SP minus CP. अब 180 minus x number of units are this is the price is given per unit, and x number of units are produced. So the x multiplied by 180 minus x will be SP, selling price, and cost price is already given. Cost price is x square plus 60x plus 50. So profit will be what? SP minus CP. So from that you will get this equation, 120x minus 2x square minus 50. Just it's a simple calculation. Now this will be your profit function. This you have to differentiate with x, and that gives me 120 minus 4x. Now as per our derivative test, we will be equating this with 0, p dash x. Then what we will get it? Number of units. So x is equal to 30. Now p double dash, that is second order derivative, is 4 only, because 120 is a constant. Derivative of minus 4x will be minus 4. And here it comes a constant function, and therefore the number of units will not change. And then what do we say? That p double dash of 30 will be minus 4, which is less than 0, and hence the maximum profit is for 30 units. तो ये बहुत ही सिंपल है. मैं फिर से एक बार कुछ स्टेप्स फिर से बोल देती हूँ. What you have to do is define the function, take the derivative, first order derivative, equate it with 0, you will get the value of x. Then again differentiate f dash x with f double dash x, second order derivative लो. अगर second order derivative constant आ गया तो example is only solved. You will get directly the values. Thank you. So be with us on P-eduKUL digital platform. You can also go through the videos of accountancy, economics, SP and OC. Be with us. Stay with us. If you have any doubts, you can join us on the live doubt clearing sessions. Thank you.